So I would like to also say that, we have our head of laboratory here. So I actually belongs to architectural design laboratory, and our head of laboratory is Professor Toto, and Professor Toto attended this lecture as well. Professor Toto, Pak Toto.
I don't know where.
Hello.
Ada. Nah, itu
Hello,
dia.
hello.
Toto.
Hello, nice
Hello,
to
good
meet you.
evening.
I'm gonna take a picture of this full screen.
Yeah.
Okay, we can take picture first.
Somebody wants me to start.
Yeah. Okay. So I will give you a sign. I will give you time to start, but at the moment we have to get like a short, brief introduction from the coordinator first, and then I will give time for your presentation. Okay. Pak Iwan.
Ya, oke. Terima kasih. Saya akan mengucapkan dalam bahasa saja. Nanti akan disampaikan oleh Bu Fenty dalam sebagai moderator lebih lanjut. Iya, terima kasih atas kehadirannya. Thank you for joining us, Lucelia. Dalam hari ini, pada sore hari ini kita akan menerima kuliah tamu dari Profesor Lucelia terkait Designing for Climate Resilience. Terima kasih bagi semua mahasiswa di kelas PA3. Manfaatkan kesempatan ini untuk banyak belajar dari Profesor Lucelia terkait dengan climate resilience seperti itu. Nanti kuliah kurang lebih akan berjalan selama 30 menit. Nanti manfaatkan 15 menit setelah 30 menit untuk sesi tanya jawab dan pergunakan dengan baik kesempatan ini. Terima kasih. Begitu. Selanjutnya Bu Dewi, monggo bisa membuka acara pada hari ini.
Oke. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. First of all, I would like to say thank you to Professor Lucelia Rodrigues for your time and willingness to share your experience and knowledge with us. Secondly, I also want to thank to all participants, students who have attended this guest lecture. The mostly students who attend this lecture are from the Architectural Design Studio 3. Besides, I also saw some lectures here. On this occasion, Professor Lucelia Rodrigues will discuss about designing for climate resilience. This topic is in line with our studio's topic of environmental resilience. Hopefully, this topic will provide input to all of us, especially to solve the problem discussed. May it will be given beneficial to all of us. All right, let's start this session. Professor Lucelia, time is yours. Thank you.
Baik, selanjutnya acara kami serahkan kepada moderator. Bu Dewi, terima kasih atas sambutannya kepada moderator. Selanjutnya terima kasih. Selanjutnya kepada Bu Fenty, silakan.
Okay, thank you, Pak Iwan. So today we have a special guest. She was my supervisor when I was studying my master's degree in Nottingham. Her name is Professor Lucelia Rodrigues, and she is a chair in Sustainable and Resilient Cities, Director of Transport, Mobility and Cities at Nottingham, and also course director of Master of Architecture in Architecture and Sustainable Design, University of Nottingham, United Kingdom. So today she will explain about designing for climate resilience. So I hope you all enjoy her lecture and take notes as much as possible and use this session of question and answer to ask her about detailed things about the designing for climate resilience. So it's very rare to have her here. So I hope that you can enjoy the lecture, and I would like to give the time to Lucelia. Please, Lucelia, you can start your presentation.
Thanks very much for the kind introductions from everybody. I didn't understand all of them, but you're so very kind. It's very kind of you to have me here. That's one of the benefits of what we're going through, which is not very nice, but it does mean that we can connect better and we can talk cross boundaries and cross frontiers. And I think that's really exciting. So I hope I get to influence a little bit of your design. and a little bit of your thinking in design and potentially your future careers. Maybe even see some of you come to work with me in the future like Fenty did. It was such a pleasure having her, and I can't believe how long it's been. But it does feel like yesterday, but it's been a long time. It's great to see her again. So Fenty asked me to talk about designing in the context of resilience, which I think is the focus of your work. And my particular side of this always been in relation to the climate. So I know you've got worries in Indonesia about resilience to extreme weather climates and when you have to deal with, for example, floods or tsunamis, which is not so much of my area. My area is more about the building design and how the building design can help to cope with future climates and the changes in climate that are about to come. So I come from the Department of Architecture, Beauty, Environment at the University of Nottingham. We are one of the largest in the country in the UK, one of the top as well. We're usually within the top 5. We have more than 1,000 students, and it's a mix of architects and engineers, but all work in the built environment. We have a very strong sustainability agenda as part of our teaching. I run the masters that Fenty attended, as well as teaching across other years. But in particular, I think we're quite strong in the integration of sustainability into the thinking and the design. In this link, so last year, not every year we have an end of year show that exhibits all the students' work from across the year. Of course, this last year we did that online as opposed to be a physical big celebration. I still remember when Fenty was there for her end of year show and celebration. But the advantage of that is that you can actually have a look at some of the work. So if you go to the link, you can see some of the work from across all years in our university. Personally, my philosophy is not that I want to protect the environment myself, but I want to educate particular designers and architects so they are protecting the environment, they're designing well, so the environment doesn't need protecting. So that's the philosophy behind my teaching and the philosophy behind my research. I'm very research active. I lead research across the university in the issue of sustainability and resilience in cities. And that's across all faculties and all subject areas, which is really exciting too, because this is a challenge that is very multidisciplinary. Now, I talked before I tell you, you probably have some of this background already in mind, but before I tell you about some of our projects, that I should give you a bit of background and a bit of clarification on the terms we use. And I start by putting up this phrase that one of my PhD students, who is from Myanmar, so I'll show some of her work later on. She called one of our latest papers with this title, "Everything has changed, yet something must change." And that's a reference to the fact that, yes, the world has changed so significantly in the last few years, in particular this last year, yet we're not doing it right from a design perspective, because we're still designing for today and we're still designing with short-term view. So we must change that now. To clarify some of the terms we use, we always talk about climate change. So, well, when we talk about global warming, that's what the rise in temperature is. The climate change is a consequence of global warming, because we have the rise in temperature, then as a consequence of climate change. And that might not be just warming, it might be extreme weather scenarios when we have, for example, here in Nottingham, I can't remember if the year Fenty was here, it snowed, but mostly it doesn't snow very much, just a little bit. But in the last few years, we're going from feeling quite warm even through winter to suddenly have big snowstorms. So it's not that it's just getting warmer, but it's getting more extreme. And that's what climate change is about. And of course, you're familiar that in the United Nations in 2018 said that we all need to do something about this now. This is an absolute emergency. We need to keep the changes or the warming to a maximum of 1.5 degrees. Otherwise, we are going to face really serious consequences. Now, when the United Nations talks about this, it talks about greenhouse gas emissions. Greenhouse gases include carbon dioxide, methane, nitrous oxide, and other gases. And they are the ones that stay in the Earth's atmosphere, protecting the atmosphere. When we have too much of it, we allow too much of the heat of the sun to come in and stay, because it's insulating the Earth, and that's how global warming starts. And we often refer to carbon dioxide only because in the built environment, I mean, well, on Earth in general, carbon dioxide is the biggest contributor and the most common of those gases, and therefore is the one that we have to tackle more closely. You probably see that as a result of what's been happening and as a result of the announcement in 2018, there's been a lot of climate emergency, let's declare climate emergency across the globe. And that's great because suddenly this came into everyone's mind and came into the focus in the news and everywhere. And that's perfect. We want that to happen. And as I always say, I want you to panic because you designers, you have a massive responsibility on tackling this. So it's the moment for us to panic so we can actually make a big change. As a result of it, many countries and many cities, such as Nottingham, have committed to delivering carbon neutrality. So as we said that carbon dioxide is the biggest contributor. So often we say, actually, I want to be carbon neutral, or I want to make a positive contribution, so I want to be carbon negative. Nottingham has signed up to be the first carbon neutral city in the UK in 2028, so that's really soon. And there's, of course, a lot of work to do before we can get there. But it's a move in the right direction until we got to face COVID and the changes that happened this year. And suddenly COVID came to the first frame and climate emergency became, well, it just slipped to the back. But it can't, because climate emergencies or climate change mitigation, it has to still be our main priority, because it's a much bigger issue than COVID and will kill a lot more people in the years to come if we don't keep the temperature to at least, the warming to at least 1.5, which is very hard. So they have collided, but it doesn't mean that we can't tackle both. In fact, the fact that suddenly everything has changed and we have been pushed to change, you know, everyone is in a different location now, but we're all together in my basement, which is a very odd concept. But I think the fact that everything has changed gives us a new platform and a new starting point to do things right, to make things new. So I think that's a good thing. And one of the things that we've seen is a big drop on carbon emissions. That's the forecast for this year's carbon emissions. Even though we're expecting the curve has been rising and rising and rising, even though we're all trying to reduce it. We haven't done very well so far. But this year actually might have seen a reduction. And I'm not sure that reduction is fully sustainable, because I'm not sure we're going to stay in the current arrangements for a very long time. But there are certain things that could be sustainable and it could help us to rethink the way we approach the carbon emissions and the issues in the built environment. And many cities across the globe have signed up for that proposition of addressing COVID recovery or pandemic recovery and climate change together. So use the green agenda and sustainability as the prime means of reigniting the economy and getting economies and countries back on track. So you guys, if you learn to design for climate change, if you learn to design for climate resilience, you'll be at the forefront and you'll be the best professionals at the right time in the right place to deal with this and to tackle this. So you'll be very well positioned. Now, this is the design issue. And this is finally being recognized across the globe. In the UK, architecture is, let's say, managed by the Royal Institute of British Architects, the RIBA. And they're very famous for actually pushing the agenda, or their agenda across the globe, and many countries follow what RIBA has to say. And they have been very, very late at recognizing the climate emergency is the design issue, but they have done it now. And you can see here Alan Jones, the president, saying climate changes changes here. We've got to do something as designers. And as a consequence, RIBA has looked at the Sustainable Development Goals that you might be familiar with, the United Nations has released, and said, well, at least these ones on the right have to be dealt with by all designers and architects. So it means that designers have to design for good health and well-being, or at least that your design will have an impact on good health and well-being. Will have an impact on water cycles, on carbon emissions, on sustainable life cycle, on sustainable connectivity and transport, communities, values, social value, net zero embodied carbon, whole life emissions, and sustainable land and ecology. So you can see your role as a designer is very vast. And there's a lot of things you have to learn and a lot of things you have to think, because your design, you have an impact on at least all of those issues on the right. And here there's a breakdown of those issues. We're starting from net zero operational carbon. So we said carbon is a big contributor to climate change. So one of the hardest issues to tackle is to reduce operational carbon, which is the carbon released while the building is being used. So if you have your lighting on, your computer plugged in in your socket, maybe heating or cooling on, you're releasing carbon because you're using energy to keep those things going. So reducing operational carbon is to do with reducing that need for energy use to a minimum. And therefore it is a design issue because you have to deliver comfort without reliance on those mechanical means. The other issue of net embodied carbon is to do with how much carbon is released when your materials for your buildings are being sourced, manufactured, transported, assembled on site and constructed and getting ready. So it's an issue that we haven't in the last few years given so much attention, but it's becoming bigger and bigger as we start to reduce the operational carbon. So when we make our buildings energy efficient and we use less energy for lighting, heating, cooling, etc., then the energy needed to produce the building, to make it ready to be used, becomes more significant. And I'm going to focus a lot on those issues and the good health and well-being, because those are the prime issues you have to address right at the beginning of the design. So in good health and well-being and sustainable communities and social value, we're talking about keeping people happy, comfortable, and therefore productive. And that's again a design issue. If your building is not comfortable, people can't be healthy in it. They can't be productive. So if they're slightly too hot or slightly too cold, or if the air quality is not good enough, they are not going to deliver what they have to deliver. They're not going to live well. They're not going to sleep well. And therefore, it's your responsibility to ensure these people are healthy and happy in their buildings. It's a lot of things for you, isn't it? So to break down the carbon emissions issue, we can see that across the world, buildings respond. So just buildings, not just the industry to produce the buildings, without even counting transport getting to sites, just operational building carbon is 28% across the globe, and buildings and materials and constructions alone is 11%. So without accounting for the wider implications of the buildings, we already have a really big chunk of the carbon emissions globally. And all of those are directly as a direct result of design. Typically, a building emissions is the operational, so the building used, well, the energy used while we occupy the buildings, the embodied carbon, which is the energy used to produce the building, and demolition disposal, which is generally a smaller portion. So I like this phrase from this institution called Architecture 2030, which is an organization that just brought architects together to deal with the climate emergency. So architects that believe in climate emergency. And they have this quote, transform the built environment from the major contribution of greenhouse gases emissions to a central solution to the climate crisis. And that's your role, is to turn our built environment from the problem into the solution. And that's quite a big role. This is a little diagram I often use to try to explain where your design could have an influence. So for example, you can see on the left side that typical carbon emissions from a building. Manufacturing construction is a portion of that gray arrow. Operational maintenance is usually a larger portion, and then demolition disposal is a smaller portion. The building lifetime includes the manufacturing all the way to disposal, but the actual occupancy time or the time the building is being used is a smaller portion of that. So that combined that has the results on the carbon emissions of the buildings within the building's lifetime. If you look to the right, there's some ideas of things that you could be tackling to reduce the carbon emissions of the built environment. For example, you could be looking at the manufacturing process and the materials and delivery to try to reduce how much carbon is released when it's being sourced, when it's being manufactured, when it's being placed on site, when people are coming and going from your site and being transferred to construct and so on. With an operational maintenance, you have to look at the design, the energy use, look at generation and storage within the building. Occupancy, demand side management, that's again a design issue. That means making people use less energy, but not because you don't want them to take a shower or you want them to be cold or hot. Because you're delivering comfort without them needing to use energy. So it's a really big design issue. And the other aspect of this is perhaps thinking about the wider implication, because sometimes a building cannot be zero carbon because you are in an urban context, there's limitations of land, limitations of financial limitations, there's certain things that you can't overcome. So what about thinking about its insertion in the community or in the city, and perhaps there is a balance that can be achieved by looking widely at the community. For example, by promoting active transport means or active mobility means, so people can walk and cycle more or more easily to your building, by looking at energy generation within the community and then sharing between the buildings and so on. And just to make it more confusing for you, when we say zero carbon, there's loads of different descriptions to that. So there isn't let's say, a way that describes zero carbon for everybody to understand. So quite like what Sonia has done just recently, she looked across the world what zero carbon means, and she found out that there's 4 different definitions. One that is really nearly zero carbon, so a low energy building is the yellow one. Then you go beyond that and actually a net zero energy building. So when the carbons from energy are net zero, not necessarily the rest, but just really energy. Then you have a net zero carbon building. So when it's including wider carbon implications and wider energy implications. And finally, the one that also includes embodied carbon, which is the issue of materials, which often is the last one to be tackled. So you can see that if you get confused with the term net zero carbon and net zero carbon, you're not alone. Everybody does. It's a difficult thing to think. But I found this quite useful to look at. So on the right, you can see, on the left is where you can find that reference. On the right, you can see what they mean. So they actually say that there's 2 net zero carbons propositions. One when you think about construction too, and the other one when you only look at operational energy. And then you can follow the lines to see what you would have to tackle if you're going one direction or the other. And to bring something else to the mix in terms of your responsibility as a designer, then we have the consequences of climate change and the implications, which is actually the main focus of this talk. And by that I mean, well, actually, your climate is changing, you know that. Indonesia probably experiences even more than we've done here, or in Brazil, where I come from. So shouldn't we be designing to take that into account? Well, how long do you think your building is going to be occupied? 1 year, 2 years, 60 years, 100 years? How is it going to look like in 100 years' time? I found this phrase very enlightening. We need to be really serious about not having houses where people sit and cook and die. I mean, perhaps a bit simplistic to put in, but it's not untrue, because the way we've been designing our cities, we are actually increasing the temperatures within the inner cities and neighborhoods, because we put so much concrete and so much reflective surfaces, absorbent surfaces, and very little greenery. And we don't think about our buildings very carefully, don't design them very well, and therefore we're accumulating more and more heat. In some cities, the difference between being in the city and just outside the cities is up to 13 degrees. Now, this is huge, isn't it? Because I know Indonesia is not extremely hot. So perhaps, I know you have hot and humid climate, and I know that's uncomfortable, but you don't experience 40 or 50 degrees, which is extreme heat, right? Well, if your cities are badly designed and your buildings are badly designed, it could easily increase the temperatures in the inner city by at least 10 degrees. So you go from what is manageable, and I would imagine you guys experience very frequently 27, 28 degrees temperature with high humidity, which is very uncomfortable. But imagine if that temperature goes up by 5, 7, or 10 degrees, just because you're designing your built environment badly. And that's happening all across the world. And there's a lot of research proving the heat island effect is a big issue. So you suddenly go from what it was manageable to extremely uncomfortable and making your life a lot harder. And what have people been doing over the years? You put an air conditioning unit, because that's the easiest way to resolve that. Is it going above 30? Switch on the air conditioning. And of course, that has 2 problems. 1, you're using energy to condition a space. 2, your air conditioning is pumping hot air out, right? and therefore contributing to make it even hotter. And then you need more air conditioning because your conditioner is making it hotter. And you can see what a bad cycle we are into now. So I then say that you have three things to deal with now. We have the climate mitigation, we have COVID and pandemic, and potentially all the pandemics that are to come. But we also have climate adaptation, so designed to be safe and resilient to whatever's to come. So how would you do that? Well, good design, and note that I put sustainable between brackets because I think all design has to be sustainable. So that just means it's good design. If you're not addressing sustainability, you're not doing good design. Therefore, let's talk about good design. So good design will deliver high comfort levels with very low energy use. And in order for that to be true, you have to make really clever decisions in relation to where your building is sitting, what is the orientation of your building and your windows, what is the layout of your building and where things are placed, what's your window design, which is, it allows daylight. You can see some sunshine falling onto me right now. So allows sunshine in, daylight in, also allows heat and cooling to get through really quickly. So the window design are very key. And of course, ventilation goes with that, and pollution, if you want to bring something else to the mix. Also thinking about insulation, thermal mass and shading. We also have to reduce the construction impact, we've discussed briefly already, and also tap into low carbon energy sources. So there are certain things, for example, I'm not going to tell you that you can't use any energy in your home, because I think you still need to cook, you still need to shower, you still need to use your computer, and you're going to need lighting certain times of the day. All I'm saying is that I'm going to reduce your need to a minimum, so then you can tap into clean energy sources. Because if you have a really large need for energy, the clean energy sources are never going to be enough, because they need more space, they're expensive. In some countries, they're kind of getting to be enough now, like Denmark, but not most countries would suffer from that. So once you can't reduce any longer your energy need in your building, then you should tap into clean energy generation, either on site, so integrated within your building, or within the community, or widely when you go to energy suppliers. And finally, of course, there's the issue of climate resilient buildings, which is the one I'm going to concentrate more on the next section. So there you're considering global warming, so the temperature is getting hotter, and what is the implication of that in your building? You're going to consider climate change. So is it just hotter, or is it extreme? And is it raining more, or is it raining less? What are you going to experience in the near and far future? There's also an issue of lifestyle changes that might come with the climate changes. So we might start culturally spending more or less time outside, or living in larger units, family units, or smaller family units. It might be a reflection of climate, or might be a reflection of economy, but we need to try to think about that. And therefore we need to be adaptable and flexible in our design. And that's a big part of being sustainable. So I'm going to show you some examples of some of the projects I went through over the years. I'm just going to check my time. I think I'm okay. Yeah, there's a lot more, but I try to concentrate more on the ones that perhaps are more linked to your reality in Indonesia from a climate perspective, and a bit of an architecture thinking. So I started getting into the climate resilience issue because when I was doing my PhD back in Nottingham, I finished in 2008, I think. I started working on the creative managed homes, which is what you can see on the screen. They are 8 low energy homes that have been designed to meet various levels of sustainability and energy efficiency. And I was involved in designing and assessing some of them. And through that, my thinking was actually, it's great that we're actually designing for winter time, but are we thinking about the future? Because yeah, you think about the UK and most people think it's cold and wet for the whole year. And it kind of is, but it's not quite the right thing to think about, because actually, I don't know if Fenty did experience overheating when she was here in her student accommodation. But most of the students that come from abroad, international students, will be shocked to be suffering from being extremely hot in their rooms over the summer, even though outside often doesn't go above 25 degrees. it does sometimes go to 30, but that's kind of extreme situation. So we're going to tell you more now. So, for example, one of the houses that I've investigated all of them, but the house in the middle is the red roof, the BSF house, is one that has a very clear example I can show you. So the BSF house was designed to be energy efficient and affordable. So the thinking at the time, it opened in 2008, so it's before a lot of changes in regulations happened. The thinking was from BASF, which is a chemical company. So BASF, for the ones that are old enough like me, you probably think of cassette tapes when you hear the BASF, but they produce a lot of the chemicals that go into construction materials. For the younger ones, you don't even know what cassette tape is. So that's a joke that doesn't work with you. But you might not see BASF labeled on buildings, because what they actually do is produce the stuff that goes into the materials that go into the buildings. So you then see the buildings, the materials in the buildings. And they have built across the world, particularly in Germany, where they're from, a few buildings to demonstrate that their products can deliver sustainability and energy efficiency. And the BASF house at the University of Nottingham campus was the first one in the UK. And the intention was to show that actually we can come as nearly as possible to net zero carbon in a way that is affordable and economic, and in a way that we can use as much as possible off-site manufacturing facilities, because one of the biggest issues in the UK is skills shortage. So services are quite expensive here, and you don't really get a lot of skilled people coming to site to build homes. So there's usually a lot of building buildings in general, a lot of waste on site, and it's an expensive business. So there's a serious issue of skill shortage. Also, we wanted to address the lack of available building land. So it's a very compact house, and offer heating and cooling solutions to ensure comfortable living. Back there, that meant that the combination wouldn't allow them to do a lot of renewable energy, because renewable energy was too expensive and they want to be affordable. But you can see the result of the house. It was built very quickly. The basement took about 4 days. The first floor and above was 1 day to get it all finished, because it was all manufactured off site and just brought into site. And it performs generally really well. So I did modeling for it, measurement, certification, and monitoring over the years. And you can see in the model, it said we could achieve about 15 kWh per square meter per year, which is, well, let's say, the lowest level of energy used in a building for heating and cooling across Europe, but across most of the planet. And we use the passive house criteria, if you're familiar with that, as a threshold. So it just means reduce the energy need for heating and cooling to an absolute minimum. So through the modeling, it looked like we could achieve that. Through the monitoring, it looked like we're not too far off that. So maybe people have used it slightly differently, but in general, it was fine and achieved the same. However, the focus of that was on reducing energy need for heating, because that's what the UK mostly needs. I then looked at the performance of the house over a summer period. I think this was 2008. I've got references for the papers and things. If anyone wants to read more on in the projects, you can have a look at them, all available for free. So I looked at it and I realized that actually the bedrooms had significant amount of overheating over the summer. And you probably know very well that if your bedroom is a bit too warm, it's very hard to sleep well. So your bedrooms need to be quite cool. And actually, this is in the UK, and the two main bedrooms had temperatures above 25 degrees for almost 25% of the time. And it's considered really serious overheating in a house here if the temperatures go above 25 for more than 1% of the time. And in particular, if it goes above 28 for more than 1% of the time, then it's something you really need to tackle. Now, I say you need to tackle, but that's not in the building regulations. There's no drivers to make this happen. And therefore, people do not need to address this. They can just design for today and not for tomorrow. And so anyway, on the today, back then, I realized there was actually quite a lot of overheating in the bedrooms. So I thought, well, if I look at future weather scenarios, so in the UK, there's an organization called UK CIP, Climate Impact Scenarios for Building Modeling, and they produce weather data that looks at different emission scenarios and what could happen with the weather then. if you carry on emitting carbon, if you stop emitting carbon, if you carry on increasing our emissions of carbon and so on. There are some studies across the globe, so you can get Indonesian data too. But in short, I found that actually the issue of overheating that was real already then. It was going to really be exacerbated over the near future, and by future then it was 2020, and this is present now. But this is of course 12 years ago. So 2020 now was the future then, and it felt like a long time away. And the results of this work have really demonstrated that if you didn't design the buildings better, and bear in mind this is a house well designed, well thought through, very energy efficient, but that would be significantly overheated by now, by 2050, by 2080, and eventually people are going to have an air conditioning unit in their bedroom because it's cheap, easy, and it's probably the best or easiest way to address the issue of overheating in the bedroom. So from then, I looked at several other developments in Nottingham, including some really high profile ones that you might have heard of. You ever looked at Nottingham? So the one on the left is the Green Street, the one on the right is the Trent Basin. So I've worked with the developers and the designers to try to reduce the risk of overheating and the climate resilience of those properties. But I didn't want to concentrate a lot in the UK because I think it feels a bit further away from Indonesia than some of the other work. So this is work done in Kenya with one of my then PhD students, now a colleague, Lorna, where she was looking at learning from vernacular architecture. So it's something we do very often. I didn't mention at the beginning, but one way for you to learn about the best strategies to deal with climate in your region is to look at the vernacular architecture. When people didn't have access to air conditioning, how did they stay comfortable? And what was the strategy that they used? So Lorna has looked at Swahili vernacular architecture and implemented that in commercial building designs. And you can see some of the things that she found: light-colored surface, mutual shading, self-shading roofs with light colors and so on. And then she looked at how she could implement some of those quite easily into design schemes. So the implementation of that looked as simple as integrating external shadings and screens, integrating natural ventilation and permeable facades in places, integrating thermal mass so that temperature fluctuation could be reduced within the building. So this is very simple to integrate in the design, and yet it's not integrated most of the time. So most of the commercial buildings in Kenya are still big glass towers that you see in many other places. So she produced some guidance to be given to designers or how to implement this and how to use. So for example, they can look at the guidance to look at how to implement shading and how to work out the solar angles. And I'm sure you are learning this with your tutors, maybe on a separate class to apply in your studio or within the studio. But she worked out that actually there could be cooling savings up to 60% just from reducing the amount of sun that came into the building by implementing shading, for example. So 60% is a huge amount. Maybe it wasn't down to 100% there, but this is only by shading. You can reduce it by 60%, the need for cooling. So your carbon emissions will be reduced by 60%. So you can see this is a very clear design issue. If you don't design appropriately, and I'm not saying that you have to integrate, here there's an external shading screen overhang. That's a very simplistic way to demonstrate this, but I mean, it could be something much more exciting. It could be a mesh, could be greenery, it could be a secondary facade. There's lots of different ways to do this. The important thing to remember here is that by reducing it, by just playing with that shading coefficient, she could reduce the needs for cooling by 60%. So that's really significant. And that's her design guidance to be given for designers in Kenya, a step-by-step guidance on how to approach this. Because I think the thing that lacked the most in there is an understanding from the designers of how this could just be part of their thinking process. This other work is from Nora Garber, who did her PhD with me after doing the master's. I think Fenty has met her. So she's now a lecturer back in Saudi Arabia. And she looked at the tall buildings in Saudi Arabia, because the majority of the people live in tall buildings there. And she realized that actually there's been a lot of glazing implementation because it looks pretty. And you can imagine in an extreme climate in the Gulf region, you put a lot of glazing and get a lot of sun. What are you doing? You're just cooking people inside. But of course, to avoid people from cooking, they put air conditioning. They have to work really hard. So it's a crazy thinking process that we all got to. And if you look at the vernacular architecture on the left, the picture there, it's very little glazing. Beautiful thinking. There's a lot of permeability to the facade, and there's a lot of ventilation when the temperatures are cooler. There's thinking of using ventilation at night time when the temperature drops. But instead of that, what you really get is those drawings that you see on the top. So she looked at the climate, passive strategies, and architectural impact of the way people approach this in Saudi. And she established what was a typical approach to it, which usually would result in at 20%, 40%, or 60% of the facade being glazed. And then she looked at a combination of that with a combination of different glazing types and different insulation types and so on, to then produce a type of guidance, which I haven't included here, but just to demonstrate in the north facade, which is the image on the top, middle and top right, you can see that the amount of solar radiation you get from the facade is much smaller than the south facade. So just by trying to implement some shading and maybe some insulation or maybe some shaded walls on the south facade, you could reduce your need for cooling significantly. And it's not a big design change from aesthetic perspective at all. This other one is in Brazil, so I'm going across the globe with you. This is another one of my PhD students, Renata, who was looking at thermal comfort and energy efficiency in social housing. I know Fenty has worked on some social housing schemes when she was here, and some of the work there, probably she has spoken to you about her work. But the thing with social housing, if you can see the picture on the bottom left, is that there's a lot of repetition. So one design fits all kind of scheme, which obviously doesn't. Brazil has 8 climate zones, and that same little house there is repeated across all 8 climates. It cannot work, can it? Because it's never going to be one size fits all. So she looked at what could be done with affordable housing, particularly in 3 climates where they are most widespread, and did try to go as far as possible in terms of energy efficiency and did an economic assessment of that. So she could go back and say, well, yes, it could go this far and get it super energy efficient, but I do understand it wouldn't be affordable. So there's an optimal level and there's more investment to make it much more energy efficient and much more comfortable without the need for that extreme climate economic investment. And she found that she could increase thermal comfort by 90% by small changes on the design and the way the openings are and the shading. So the one on the right on 92% is in Curitiba, in São Paulo 98, in Porto Alegre 89, so the 3 cities she was looking at. So you can see again, just design issues are a very prime way to deal with comfort and increasing resilience. This one is a work in Mexico. He's also looking at social housing, and he's looking at several different climates and looking in particular at the resilience of those buildings to future climate scenarios. So what Erna has found is that she could increase comfort hours by 14%, 5%, and 10% in the future, just by small changes in the design. And again, she's trying to keep this very simple and very small, because we know that every brick counts in the social housing scheme. So she's not doing a double skin facade or a huge tower in the middle of the building, but she's small tweaks that could slowly improve the building. She hasn't finished yet, so there'll be some more to come. But now I'm going to show you some of May's work. So I mentioned May right at the beginning. So May's zone is from Myanmar, and which has a much closer climate to Indonesia. So you can see a lot of her work has been based around understanding vernacular architecture strategies and thinking about how could implement them in modern buildings, and also thinking about how those vernacular strategies would or would not make those buildings resilient to a climate change scenario. So this is for me one of the most beautiful combinations of images, when you can see all that a strategy that you're probably very familiar with, even more than me. Some high-level roofs, some permeability of the facades, some of the buildings being brought off the ground, so you've away from humidity and away from the animals back then, when animals were a problem. Lots of trees and shading, also shaded roof. Beautiful, beautiful thinking. Now, why have we forgotten a lot of those? I don't know, but I'm here to remind you, go back and look at it, because there's so much to learn. So she looked at 3 BMR climates in this particular, so there's several of the her work here that are relevant to you, and looked at different passive design strategies used on those houses, and looked at how, well, of course, you guys are not going to do that level of detail in the studio, but she was looking at how those small passive design strategies ideas, for example, a roof level opening that extracts warm air from right at the top of the dwellings. There may be, but just by being moved slightly or slightly bigger or slightly smaller, could significantly impact the amount of comfort you get in the buildings. So this work established a lot of that, and she also looked a lot of the traditional materials that were used, that are still used in Myanmar, against the more modern materials. And then she also looked at particular aspects of design. So for example, this one is the roof, because roof in Myanmar is a really big aspect of the typology. So you have those beautiful curved roofs, of layered roofs and lots of details. So that's a really significant part of the culture, and something that it was designed, the wood stage roof was designed with performance in mind, with comfort in mind. Not so much now, perhaps if even implemented at all, is really with, I guess, an aesthetic view as opposed to performance, but they can really help to improve comfort and help to deliver against those global warming and climate change. So she's undertaking a lot of work on this to look at the multi-stage roof parameters, and actually concluded that even though they do help a lot to deliver comfort, so it's still in today's climate, you can achieve comfort by using the roof as part of your strategy. In the near future, that's alone is not going to be enough, because climate change in Myanmar is impacting significantly. Well, the global warming is impacting climate change in Myanmar very significantly. So even that alone is not going to be enough, and we have to think harder and further and design better. The other work she looked at is that she actually did monitoring of some of the vernacular buildings and tried to learn whether they were comfortable the majority of the time. And then she looked at the future and whether they would be susceptible to extreme climate. And again, she found that they're quite good now. They still perform really well, the vernacular strategies, but in the near future, they will be at the high risk of overheating and other extreme weather events. And therefore, we have to learn from those strategies, but we have to think hard about implementing them and designing them for a future that is not what we're experiencing right now. The scary thing about this is that this future I talk about is very quick as well, because we seem to every year see more of the extreme weather events. Every year seem to experience hotter summers and maybe colder winters, or wetter seasons or drier seasons. And it just seems that, at least for me, within the last 5 to 10 years, that every year is being quite different already. And I used to think of 2020 as the future. Now it's almost the past already. Although this year doesn't count, I think, with everything that has happened, maybe we can not count that in our age. But in any case, I think it's quite scary to think about that, because when I say future, we're not talking 2100. We're talking actually tomorrow. From where our kids are going to grow in. So this other one, it was looking at the modern buildings in a similar approach, looking at particular also building with a lot of materials, because in modern life we don't really build with traditional materials anymore. And I do apologize for the sun just shining right on my face now. We're getting to winter now, so the sun has moved significantly, and I have no shading on that side. And again, she found that the modern houses that are being built right now, even the ones that are well designed, they have an extremely high risk and high vulnerability to extreme weather scenarios, in particular to overheating. And when I say overheating, overheating doesn't need to be extreme. So I'm not saying that Indonesia might start to experience 50 degrees, but I'm saying that it might start to experience 30 degrees for a longer period of time. And therefore get a lot harder for you to keep cooler, because it doesn't go up and down as it used to, or it doesn't stay at the 27, 28 for the hottest time of the year, but it stays just 2 or 3 degrees higher than that for a longer period of time. And that not only changes the whole environment, but also changes your ability and your building abilities to respond to that climate. And of course, if you get the 50 degrees every now and again, then of course that's even worse, but it's less likely that it's a problematic thing, because it's not going to happen all the time, than the issue of being just slightly hotter over time being problematic. So in Europe, there's been a much increased death rate because of some overheating in the last decade, including the UK. So when you think the UK is actually cold, for vulnerable people, let's say for elderly people in particular, being slightly warmer than they should for over a period of time results in dehydration. And if you are cold, you tend to react to it quite immediately. So an elderly person who is cold tends to try to light up a fire, sit by the fire, try to keep warm. If you're slightly warm, you don't necessarily tend to act on it because you're just slightly warm. But over a period of time, maybe a few days and a few weeks, then can lead to severe dehydration and death. So it can be a very significant and problematic issue, even in countries where extreme heat is not known to be a problem. And finally, I finish on May's on the starting point, and everything has changed and yet something must change, which is the last paper we've written. We just finished this week, where she actually is a completely different approach. This was looking at storytelling and narrative, so not simulation work as you've seen before, but looked at some documentaries and some experience in Myanmar, and try to think. If you look at the top right, you can see what's happened to the climate. So it's going from the left to the right, and the red dots are much more extreme, much warmer. So it's getting a lot more red than it had before. But what the discourse of this paper is really around the issue that housing, the delivery of housing in Myanmar is facing a lot of challenge now. There's not only climate emergency and pandemic, but there's also biodiversity erosion and social inequity. And this paper is really to ask for, as a call for action, for people to start to consider that actually new housing, new buildings need to be delivered, designed and delivered appropriately, not just for today, but for the near future, because it's not going to be very soon, not far from now, so it's not going to be very far until we all experience this extreme, I would say, sensations and experience in buildings in terms of getting just slightly hotter, or slightly too hot, or slightly too cool for a period of time, and start getting ill, uncomfortable, unproductive, and not only to say that we wind up using a lot more energy than we would otherwise. So as a reflection for you guys that are getting your education, should you get educated? Well, why is this important? The thing is really important here is that you are the guys, the designers of tomorrow. You are the people who are going to come out ready to design for a climate that has changed, for a world that is dealing with post-pandemic and needs the economy to be restarted. You're going to be designing for people who are more vulnerable, and perhaps more people who have long-term conditions as a result of being experiencing. And of course, you, the designers, who are going to design buildings that are going to use less or more energy. And therefore, this is in your hand. Do get educated, do embrace this, because not only going to put you in a very good position as a professional, but also it's going to help us all to have a better world. Thank you very much. And I think I might just be on time, but we started a bit late, so
Yeah.
sorry for that.
No problem. Thank you, Lucelia, for your excellent explanation about the climate resilience. I think we run out the time. You have a very busy day. I don't know whether you can squish it out or
Let me just,
okay.
if I can just tell people I'll be slightly late, I can do with you for 5 minutes.
Okay.
Just stay.
So, but if that case, I think I can collect the question from students and then I will send it to email to you. And if you have time, you can answer it because
Okay,
I know that
that's
it's
perfect.
a little bit hard for you to find times to give lectures. So I think thank you for your explanation. And students, you can ask. Oh, I think I will say it in bahasa instead of English. Kalian bisa nanya nanti lewat WhatsApp group ataupun email ke Pak Iwan. Nanti akan disampaikan ke Profesor Lucelia karena Profesor Lucelia habis ini ada apa namanya ke agenda lain gitu. Jadi karena ini waktunya sudah habis, jadi bisa disampaikan ke email tersebut gitu. Jadi nanti kalau mau tanya-tanya silakan tanya ke pembimbing untuk disampaikan ke Pak Iwan ataupun ke saya juga boleh. Nanti kalian bisa nanya and I will deliver it to Lucelia. And then thank you for students for listening to this lecture. I think before the closing, I would like to invite you, Lucelia, to join the breakout room for closing like about 5 minutes before you leave the meeting. I mean the virtual meeting.
Before I get on my playback.
Yeah. Buat mahasiswa, terima kasih sudah datang ke ini. Pak Iwan mungkin ada penutupan sebelum kita join ke breakout room, Pak.
Oke. Terima kasih. Ya, untuk mahasiswa, silahkan kita bisa mengakhiri saat ini. Nanti untuk tugas resume silahkan disubmit maksimal pukul 9 malam. Ya, sudah saya geser. Lalu selebihnya nanti untuk pertanyaan harap dikumpulkan ke ketua kelas masing-masing. Nanti tolong ditabulasikan berupa tabel sehingga kita bisa menata, nanti bisa diserahkan kepada Bu Celia. Seperti itu. Ya, jadi kelas A ke kelas A, kelas B ke kelas B. Lalu bisa disubmit, nanti disampaikan ke Bu Windy dan ke saya. Nanti akan kami koordinasikan lebih lanjut. Begitu Bu Fenty. Terima kasih untuk kelas A dan kelas B, untuk kelas asas APA 3.
Thank you, Lucelia. Sorry for the late. I mean, in Indonesia, we have such a, I don't know, process. So I have to greet you, the head of department have to greet you and stuff. So
I hope that wasn't too rushed.
No, I think it's fine. And students can go back to the recording if they don't understand. So yeah, that's not a big problem. So here we are. I think we are waiting for several lecturers to join this breakout. I think it's
very nice lectures and then very interesting. Yeah, because I think Myanmar is almost same with Indonesia. Myanmar, the style of the vernacular housing is almost similar in Indonesia. So
it's very similar, isn't it?
Yeah.
Used in Indonesia also, I think.
Yeah.
Yeah, I thought I've done a lot of work in the UK, but I thought it's less interesting to concentrate on that than to just talk some of the work in Myanmar and some of the work across the world because they can relate to it better, I think.
Yes.
I hope it wasn't too rushed, but there's a lot of referencing material in there that they can go back to. So if they're interested in a particular aspect of one design or one work, they can read the paper.
Yeah, I think that's good. And one more thing I learned, it's actually about the precedence. Students thinks that the precedence is coming from Western architecture.
Yeah.
That's
like,
it's always happening.
Almost the building in the president is in Western style.
Yeah,
coming from Western.
Yeah, that's why
I hope this inspires them to look closer. I know, because you have such beautiful designs there, and I actually haven't even mentioned the shop houses in this presentation, but there's so much to learn from the shop houses, kind of style.
Yes,
and I know you guys have quite a lot there.
Yeah. They tend to forget their own heritage and just look at the Western architecture. So I think from your explanation,
I could do a whole lecture on that if you wanted. Because it's about just designing glass towers and and thinking that's the way forward. And it's kind of the opposite, isn't it?
Yeah, that's it. So thank you very much for the lecture. I think this is very precious for us. I always say to my students that our heritage, like our vernacular architecture, is really, really important, but they don't believe it until maybe they see you explaining about Myanmar and stuff. So I think it's an eye-opening for us that actually people look at our vernacular architecture. So yeah, thank you so much, and I will. I mean, I need to stop the recording.